Hello and welcome to today's lesson where we're going to look at how to measure the wave speed in a ripple tank, which is part of the waves topic in GCSE Separate Science Physics. So in today's lesson we're going to look at how you can determine the wave speed in a water wave. So if we're successful and we learn in today's lesson, we understand how to calculate wave speed in a water wave, we can calculate the wave speed of a water wave from experimental values, and then finally we can determine the accuracy of different experimental values that you would gain in this experiment. Now this falls into the following part of the GCSE Separate Science Physics Specification 4.6.1.2, the properties of waves, and in particular this is a required practical activity where you've got to make observations to identify the suitability of apparatus to measure frequency, wavelength and the speed of waves in a ripple tank. So in previous lessons we've looked at the idea of wave speed. Wave speed is the speed in which the energy is transferred through a medium. It's the distance a wave covers in 1 second, and we can calculate wave speed with the following equation. Wave speed in meters per second is equal to frequency in hertz times by wavelength in meters. So to calculate the wave speed in an investigation, the frequency and the wavelength should be measured, and this can be used to determine the wave speed. So if we're successful in this investigation, we should be able to calculate the wave speed of a wave in water from the measurements of wavelength and frequency. So what do we need? We need a ripple tank, a low voltage power supply, a lamp and a meter ruler. So you would set up the ripple tank as shown in a diagram. Make sure there's a large sheet of white cardboard paper on the floor under the tank. You then pour water to a depth of about 5 millimeters in the tank. You'd adjust the height of the wooden rod so that it just touches the surface of the water. Switch on an overhead lamp and an electric motor. You'd then adjust the speed of the motor so you're producing low frequency water waves in your ripple tank. You'd then adjust the height of the lamp so the patterns of the waves can be clearly seen on the white card. You'd then place a meter ruler at a right angle shown in the pattern on the card, and then you'd measure across as many waves as you can, then divide that length by the number of waves. This gives you the wavelength of the wave. You would record that in a table. You'd then count the number of waves passing a point in a pattern over a given time, say for example 10 seconds. You'd then divide the number of waves counted by 10. This gives the frequency of the waves, and you record this value in your table. You can then calculate the speed by doing wave speed is equal to frequency times by wavelength. So this is very important because you should be able to calculate the wave speed from water waves in a ripple tank measuring frequency and wavelength. So just to clarify what happens, what would happen if you set up your ripple tank correctly, you would observe the following observation on the paper on the card underneath the ripple tank. Now each ripple is the peak of a wave. Now when waves are observed in this orientation, we call the ripple the wavefront because it's the start of a new wave. So this is an example of what we call a wavefront diagram. Now you should really use a darkened lab because it makes it easy to observe the wave pattern. And so to measure the wavelength, you will need to position a meter ruler at right angles to the projected wavefronts. You'd measure across as many waves as possible, then divide the total length by the number of waves. So as shown on the picture, we've placed our ruler at right angles to the wavefronts, and we're measuring across as many waves as possible, then we're dividing by the total number of waves. Now we've got to ensure the ruler is placed perpendicular to the wavefronts, otherwise the wavelength is measured inaccurately. This is an example of parallax error. So to reduce the impact of parallax error in your investigation, the readings should be repeated and then an average will be calculated. Now we measure over as many waves as possible and then divide by the number of waves to find the average, as it reduces the impact of the random error in the reading of the ruler to find the length. So what we can say is the percentage uncertainty in the results has decreased. The impact of your error in the results has decreased. Now also, to make this experiment more accurate, you could take a picture of this particular situation because then it will be easier to identify where the ripples are in the tank, so it further reduces the random error. So that's a very important idea. Now to measure the frequency, it's likely that no further apparatus will be used because if a motor is rotating slowly, the frequency is so low it's possible to count the number of waves passing a point over a given time. You then divide the number of waves by the time you've measured it for to work out the frequency. So you would select a point in the ripple tank measuring the area. So then what you do is you count how many waves go past that point in a certain time. Then to find the frequency, divide the waves by the time. Now the larger the time which the measurement is taken over, the lower the impact of the random error in miscounting the waves. So the larger the time, the lower the percentage uncertainty. The larger the number of waves counted, the lower the percentage uncertainty, the lower the impact of your error on the values. Now it's difficult for a human to count the number of waves accurately because there could be quite a lot every second, so to reduce the random error you can record a video and count the number of waves in a certain time in slow motion. But for this to work, the video has to include the stopwatch, because you would need to slow it down to count the number of waves passing a point in a particular time. So when you've done that, you would make a results table like this. You would work out the wavelength of the water wave and write it down. You'd work out the frequency of the water wave in hertz and you'd write it down. Then to work out the wave speed, you'd multiply the two values by each other. Now the number of decimal places is given by the number of decimal places the measuring device can record to. So in this example, our meter ruler can measure to 3 decimal places, so we record it to 3 decimal places. So what have we learned in this investigation? Hopefully you can make observations to identify the suitability of apparatus to measure frequency, wavelength and the speed of waves in a ripple tank and take appropriate measurements. So if we've been successful and we've learned in today's lesson, you can understand how to calculate wave speed in a water wave, calculate the wave speed of a water wave from experimental values and determine the accuracy of the different experimental values. I hope you've enjoyed today's lesson where we've looked at how to calculate the wave speed in a ripple tank, which is a required practical for GCSE Separate Science Physics. Thank you very much for watching and have a lovely day.